Hey y'all, today we're going to talk about equations. So the first thing, let's look at one-step equations. There's only one thing to do to solve for the variable x. An equation is a math sentence that does contain an equal sign. Okay, so it has that equal sign. You'll see expressions. Expressions are just letters and numbers combined in terms to make a statement, but an actual equation contains an equal sign. So the goal of solving an equation is to find the value of the variable. Now, what is a variable again? A variable is a letter that represents an unknown number. So the first thing we want to do is isolate the variable on one side of the equation using inverse operation. So let's go over inverse operation. Inverse operation is doing the opposite of what is shown. So what is the inverse of addition? Subtraction. What is the inverse of subtraction? Addition. Now, the inverse of multiplication, division. And the inverse of division, multiplication. All right, let's talk about this. What does this actually mean? So equations are like balanced seesaws, or it's like lifting weights. Everything must be balanced. Whatever you do to one side, you must do to the other side of the equation. So the first thing that we want to do, we're going to look at this little example here. We're going to locate the variable. So if I have x plus 5 equals 8, locating that variable, the variable is x. We want to move the constant, the number without the letter, to the opposite side. We're going to do the opposite operation to get that number inversed, get it away from the variable. So right now on the left we have x plus 5 equals 8. The opposite, the inverse of adding 5 would be to subtract 5. So that's why you see that they subtracted 5 on both sides. When they subtracted that, it canceled away. Now we have x equals 3. Just like a balance beam, a seesaw, you need to keep the same thing on the left and the right happening at all times. So that's why on the left side of the equal sign we subtracted 5, and on the right side we subtracted 5. Let's try this one on the right side. Y minus 8 equals 15. What operation are we going to use to inverse this? Good. Addition. We're going to add 8 on both sides. When we subtract 8 and add 8, that cancels away. We're left with y on the left side, so y equals 15 plus 8, so y equals 23. Now, let's look at a problem where we have to divide. So, 8x equals 56. Our first operation is to get the variable by itself. 8x. 8 times x equals 56. Well, what is the opposite of multiplication? Division. So we're going to divide that by 8, and when we divide, it cancels that 8 away. So on the left, we're left with x equals, and on the right, 56 divided by 8, 7. X equals 7. So let's look at this example on our own. A divided by 5 equals 40. Well, if this is a division problem, what operation does the fraction represent? A division problem. What is the inverse of that operation? So what is the opposite of division? Multiplication. So the opposite of dividing is to multiply. You're going to take the number that's with the variable and multiply it on both sides. So times 5 times 5. So A equals, well, what is 40 times 5? You're doing the opposite of division, so you are multiplying. 40 times 5 is going to be 200. Now, to check your work, you could simply grab your calculator and checking your work, you're saying A equals 200. Well, my original problem was A divided by 5 equals 40. So if we plug A in where A is supposed to be, 200, divided by what we originally had, 5, equals. So yes, it does check out. 40 does equal what we originally had of 40. Have a great day.